Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to cloud test lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
It is always an instance of the java.Lang.thread. No matter what, if I want to extend the thread class or implement the runnable interface, it is always a thread in Java is always an instance of the java.Lang.thread. So folks, when we create a class by implementing the runnable interface, so what are we doing? First, we create a runnable object. You see? We created a runnable object and we create a thread object. If you see here, by passing the runnable object, we are creating a thread object. We are passing the runnable object that is created here. Because there is an overloaded constructor, I am creating a thread by passing the runnable object and I am naming it as thread1. And then I am creating one more thread object by passing the same runnable object and I am naming it as thread2. Right? And I am starting these two threads. So, folks, could someone, what happens when I say t.start? It goes to this specific run method and it prints from 1 to 5. And even this thread, the second thread, it also does the same thing. It goes and print the numbers from 1 to 5. So, folks, you see the output? I started thread 1 first, but thread 2 got executed. And then the control came to thread 1. And then it came to thread 2. And then thread 1. They're executing in parallel, folks. You see it here? See, I have started these two threads. So, what does these two threads does? They execute the code inside the runnable example run method. So, what do I have in the run method? I'm printing from 1 to 5. And along with what am I doing? I'm printing the current thread name also. So that I understand which thread is executing this code. Right? And then what I did? Okay, first understand this and then I'll explain this. So it's like they're spanning across. I started the thread 1 first, right? I started the thread 1 first. And then I started the thread 2. But still, the thread 2 executed first and then thread 1 and then thread 2, right? This behavior is not guaranteed. When I run it for multiple times, the behavior might vary. Because when we start the threads, they can span in parallel. We cannot say thread 1 executes first, thread 2 next. We cannot guarantee that. So folks, you understand these two ways of creating threads. One is by extending the thread class and the other is by implementing the runnable interface. So folks, any doubts in the code that we write? Like first we have created a thread class by extending the thread class. So the first way of creating a thread by extending the thread class, we override the run method. So how do we start this thread? We have to create a thread object and we start the thread. So there are different states for the thread. So when we create the thread object, but we haven't yet invoked start method on the thread is set to be in the new state. And when we start the thread, it comes to the runnable. And when the thread scheduler picks it, it goes to the running phase. And from there, it can optionally go to wait or sleep states. And then when it is done with the wait or the sleep, it again comes back to runnable. And then when the thread completes its task, it goes to the next thread. What is the task for the thread? The code inside the run method is the task for the thread. So when we run it, what are we exactly doing with the thread? We are calculating the sum of first 9 natural numbers. That is what we are doing in this thread, in the run method. So it just prints us the sum, and along with it, it is printing us the thread name also. We have set name method to set the name for the thread. We made it as thread111. And here we have the get name method to get the thread name, and we are printing it here. If you see the code inside the run method, it is executed by the default thread, the main thread. So the name of that thread is main. And then we have seen one more way of creating threads.
May I have one doubt? Not a doubt actually, but just one small experiment. So in thread1.java, if we again start the thread like t.start, like if we do it twice, what happens? Like does it
gives you an error. See, it gives an exception. It says illegal thread state exception. The thread is already started. When we try to start it again, it throws an exception. Illegal thread state exception.
Okay. Okay. And just one more. Okay, yeah, fine. I think, yeah.
No, you could ask me. When a thread is already started, if we try to start it again, it throws an illegal thread state exception.
So, okay. Yeah, I got it.
Neha?
Yes, Shani?
How to determine what to use? I mean, when to use the runnable and when to use the class? Only if you are extending another class for a desired class, only then we have to use the runnable. Because once we use the extend keyword, then only implement is remaining. So is that the only
See, when we do both ways, if you observe the thread class, right, the thread class doesn't do anything. It implements the runnable interface. We have the thread class, right? If you go to this code, what does thread class do? It implements the runnable interface. I don't think I have. Yes. Anyway, even though I don't have like the Java code, even the dot class, you see, it is implementing the runnable interface, right?
Okay.
And it has some behavior on to make it function as a thread. There are some methods that are defined in the thread. But the bottom line, it is also implementing the runnable interface, right?
Yeah.
So, for example, let's say I have something, the account creation, I want to do it in a separate thread, right? If I extend the thread class, if I have a base class account, I cannot say my savings account can extend it and have thread behavior also. That cannot be done because I cannot extend two different classes in Java, right?
Oh, yeah.
So in that case, we go with the implementation of the runnable interface so that we have the ability to extend other class.
Okay. Okay. So the performance will be same because anyway the thread is implementing the runnable already, right?
Yes. But the performance gets hit whenever we are trying to create like multiple threads. See, actually what happens is, from the performance standpoint, if we create a new thread, right, it causes a performance overhead. That is the end slide we're going to discuss about anyway.
Okay.
I don't want to
confuse people. Yeah, that's fine.
By mixing it. So, are you people clear on the different states of a thread and two ways of creating a thread, like extending the thread class and implementing the runnable interface? In either case, a thread is always an object of java.line.thread. Even we implement the runnable interface, see, we create a runnable object and we pass the runnable object to the thread constructor. Thread has overloaded constructor folks. See, thread has a normal constructor and a constructor which takes the runnable object and which takes just the name. We can create a thread object by just giving a name. And there is one more constructor which takes a runnable object and the name of the thread. So I can just pass the runnable object and set it later, or when we pass the thread name, it sets the name for the thread. So even though when we have the runnable object, we have to create a thread class thread object by passing the runnable object. So we use the same start method in either case to start the thread. So any doubts on this?
Hello, Neha.
Yes.
I have one question. So how we can decide that we have to use synchronized keyword and volatile keyword?
See, volatile is used for variables. Okay. These are two different questions, folks.
Yeah.
Let's talk about volatile. Volatile, we make it for a variable. So basically, when there are multiple threads, right, we have discussed that there is a cache of memory that the thread maintains, right? So, but if we say a variable as volatile, it doesn't try to look up from the cache. It tries to get the exact value from the memory. It doesn't try to look up in the cache, because volatile, we make it for a variable wherein the data for the variable or the value for the variable changes very, very often. The perfect example is temperature, right?
Okay. Yeah.
Temperature changes every now and then, right? So we don't want to retrieve that from the cache. It always gets the latest value, the last modified value, the latest value. All the threads reach the modified value for the volatile variable. Okay?
Okay.
That is one question. What is the second question?
Synchronized keyword. How we can use synchronized keyword?
Whenever, if multiple threads access some code, right? When there is, in the scenario of a joint account that we discussed, right? When multiple threads access it, the behavior doesn't work as expected, right?
Yes.
It's completely the business what determines to make the code asynchronous. We see, if there is any possible effects, or errors. I'm not saying the program errors, right? There are some kind of calculation errors. What happens because of multiple threads accessing the code? Then we make the code asynchronous.
Okay. So it must take one thread at a time.
Yes. When we don't want, when multiple threads access it, if there is some, if the functionality doesn't work as expected. For example, I'm reading data from a database, let's say, right?
Okay.
So there can be multiple threads that is accessing that specific code, right? Anyone can read it. There is no harm, right? But let's say we have like the same record which is update, let's say, right? So when one thread updates it, right? You don't want other threads to go ahead and update it, so that they update the stale data, right?
Yes.
I'm just giving for an example. Might not be a perfect business scenario though. But when each time when a thread updates it, it sees the version it got. Let's say, for example, in database we have the version. Both threads got version, and both threads are trying to update it. When one thread is updated, it is version 2, right? When they are able to, if they were allowed to, update simultaneously, it's like you have two version 2 that are created in parallel, which is not the case, right?
Yes.
So we don't want them to update like simultaneously. We want like when one thread tries to update and create a new version, we just want to stop the other thread by doing this, right?
Yeah, so they can read simultaneously, but they cannot update simultaneously.
I'm just giving you an example.
Yeah.
For you to understand. There are some scenarios which can be accessed by multiple threads without any issue. There can be some part of code what you are trying to achieve with the code. They can be accessed by multiple threads without causing any issue, right?
Yes.
But there is some code which leads to functionality issue when multiple threads are accessed. In that scenario, we synchronize the code.
Okay. Okay. Thank you.
So, any other doubts in creating a thread, about the run method, about different stages of the threads? So we have different methods that are present in the thread class. So we have already seen the start method. Start method is used to start the thread in the separate path of execution. And this start method invokes the run method on the thread object. Folks, we have already seen it. We said t.start, but we haven't called the run method. But the code inside the run method is getting executed, right? So if you see this example here, this particular example, we are not calling the run method here. We're not calling, even in this example, we're not calling the run method, right? If you see this code, we are just calling the start method. What does the start method does? It starts the thread in a separate path of execution, and it internally calls the run method. As the start method is internally calling the run method is getting executed because we are not calling the run method. So how is it getting executed? The start method internally calls the run method. So what is the run method? The run method is the exact task that the thread is performing. So whenever we have a thread object using a runnable target, the run method is invoked on the runnable object. And we have seen the setName method, which is used to set the name for the thread. And folks, we have the priority, priority that can be assigned for the thread on a scale from 1 to 10. 1 is, of course, being the lowest priority and 10 being the highest priority. We can use the set priority method to set the priority and get priority to get the priority of the specific. We have something called as a daemon thread. What is a daemon thread? A daemon thread is something which runs in the background. It is a very less prioritized thread and it runs in the background. So if you want to make a specific thread as a background thread or a daemon thread, we call the set daemon on the thread and we set it to true. And folks, we have the join method on the thread. So when we call a join method on a thread, what happens? It causes the current thread to stop until the second thread completes or terminates. When the thread invokes this method on a second thread, for example, I am executing in the main thread. For example, I say t.join. So the main thread stops until the T gets completed. So folks, here, let's say in this example, right, if I'm asking it saying T2.join here. For example, let's say I have started both these threads, right? So I'm saying T2.join. So folks, what is the error that I'll get here when I say T2.join? The join thread gets and throws an step exception. It is interpret exception. So we have to handle it. So folks, let's see, I'm saying I created two threads and I'm saying T2.join. Right? So what happens when I say T2.join? The current thread. What is the thread that is executing this code? It is the main thread, right? The main thread stops and it waits until T2 is terminated. So let's see folks, when I run this, right, this doesn't get executed until T2 gets completed. The thread 2, what is this T2? We named it as the thread 2. The thread 2 should get completed and this comes as the last. I mean, it's not at the last, it comes after the execution of the thread 2. right? Let's say if I don't have this, code, folks, follow this. This is very important. When I run this, you see, this is not coming last. It has executed the main thread, which is executing this. It has executed a way back before T2, which doesn't happen when I say T2.join. Let's see the output. See here, this got executed even before thread 2 is terminated. Thread 2 is still executing, but this piece of code which is executed by the main thread is done a while before T2. That doesn't happen when I say T2.join, because when I say T2.join, what am I saying? I'm literally saying it join at the end of T2. When I'm saying T2.join, it literally means I'm asking it to join at the end of T2. So when I uncomment this code, basically when I say T2.join, right, this particular piece of code which is executed by the main thread, it waits when the program encounters this line. When it executes T2.join, it stops the main thread until T2 gets executed. See, this comes last, not the last, it comes at the end of T2. So folks, clear on this join method?
So Neha,
Yes.
the join method is always used to prevent the execution of main thread before the subthread?
No. In real-time scenarios, there will be some scenarios wherein, the second process is dependent on the first process. Let me tell you this way. In a financial domain, when we want to analyze the stock price for a week, right? There is one thread which gets the stock value for the week. And there is another thread which analyzes it and tells you, if it is increasing across the week or if it is decreasing across the week, and many more tools. So the thread which performs the analysis should wait until let me tell you this way. There are two threads. One which fetches the price details of the stock for the week, and another thread which performs the analysis, right? You cannot perform the analysis until you fetch the price, right?
Yeah.
So we can start both the threads, but I say T2.join. I start the first thread and I say T2.join. I want to make this thread wait until the other thread fetches the price details for the week, right? So in real-time scenarios, there will be like one process is dependent on the other. In such scenarios, we use the join method.
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website h2kinfosys.com. On our website h2kinfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.